For the longest time, the database world was kind of split right down the middle. On one side, you had your traditional relational databases, super reliable, with these rock-solid guarantees for your data. On the other, you had the fast, flexible NoSQL databases built for massive scale. It was always a trade-off. But what if you could have both? Well, that's what we're digging into today. We're looking at how MongoDB, a giant in the NoSQL world, brought these two worlds together with multi-document ACID transactions. And believe me, it was a total game changer.
All right, to really get this, let me paint you a picture. Imagine you're sending a friend, say, $100. You hit send, you see the money leave your account, but then nothing. It never shows up in their account. It's just gone. Poof. Vanished into the digital ether. I mean, that's the kind of nightmare scenario databases are built to prevent. And it all boils down to one really important idea.
And that core idea is what we call an ACID transaction. Now, ACID is just an acronym, but think of it as a set of promises your database makes to you. The A stands for atomicity, and that's the big one we just talked about. It means the whole operation is all or nothing. The bank transfer either fully completes or it doesn't happen at all. No in between. The other letters are just as important, though. They make sure your data stays consistent, the different operations are isolated from one another, and that once a change is saved, it's durable, meaning it's permanent. For decades, this was the absolute bedrock of the database world.
So, to really grasp why adding this was such a monumental shift for MongoDB, we first have to look at the very different ways these two database philosophies, how they think about your data.
Okay, so this is the old school, the classic relational model. You've got data for just one customer, but look at it. It's chopped up and spread out across a bunch of different interconnected tables. You've got a table for their basic info, another one for their addresses, maybe another for their purchase history. Everything is super organized and structured, for sure, but it's all separate.
So what happens when that customer decides to move? They get a new address, a new phone number. Well, now you've got a problem. You have to go in and perform this pretty complex operation that touches multiple tables, all at the same time to keep everything in sync. And to make absolutely sure you don't end up with that halfway updated mess, the whole thing has to be wrapped up in one of those ACID transactions we talked about.
But then MongoDB showed up with a radically different approach, the document model. The idea was simple, but powerful. Instead of splitting all that related data apart, why not just keep it together? So all the info for that one customer, their name, all their addresses, phone numbers, you name it, it all lives together inside a single, rich, flexible structure called a document.
And this comparison right here just nails the difference. On the left, you see that relational update. It's like a messy spider web of changes you have to coordinate. But on the right, that's the document model. You're just updating a few fields inside that one single document. It's just cleaner. It's a way more intuitive way of thinking about the data.
And here's the really fascinating thing. Just by making that one design choice to keep related data together, MongoDB inherently solved the transaction problem for the huge majority of everyday situations.
So this is a really crucial point to understand. MongoDB has always had atomicity. From day one, any operation on a single document was atomic. You could change 10 different fields inside one document, and it was guaranteed to be an all-or-nothing update. And because you're modeling your data so that related things live together, most of the time you only need to touch one document anyway.
And the data totally backs this up. According to MongoDB, for a whopping 80 to 90% of applications out there, if you just model your data the right way, using the document model, you get all the data integrity you need, right out of the box. No need for the complexity and overhead of those old-school multi-step transactions.
Okay, great. But you're probably thinking, what about that other 10 or 20%? Because let's be real, there are some absolutely critical situations where you do need that all-or-nothing guarantee across multiple, separate documents.
Yeah, we're talking about the really high-stakes stuff. Our bank transfer example is perfect. Moving money from one person's account to another. That's two different documents right there. Or think about a big supply chain system. You create a new order, which is one thing, but you also have to reduce the inventory count, which is a completely different thing. In these cases, single document atomicity just doesn't cut it.
And that's precisely why this feature was such a huge deal. You see it right here in the quote from Dharmesh Panchmatia at Cisco. It was all about getting rid of that painful choice. Developers no longer had to pick between the flexibility and power of NoSQL and the rock-solid safety of transactions for their most important mission-critical apps.
I mean, before this was built in, can you imagine what developers had to do? They had to write all this complex logic themselves, right in their application code. We're talking like 1,000 lines of really tricky code that's super easy to mess up. So by building transactions right into the database, MongoDB didn't just make developers' lives easier, it also gave a massive performance boost, because the code doesn't have to sit there and wait for the database to say, okay, after every single tiny step.
But here's the thing. This capability didn't just appear out of thin air. It wasn't like someone just flipped a switch. No, this was the final crowning piece of a very complex puzzle that the engineers at MongoDB had been carefully putting together for years. Just look at this timeline. You can see this was a methodical, multi-year journey. It all started back in 2015 when they swapped out the storage engine for one called WiredTiger. That was the bedrock. Then, step by step, they improved how their servers talk to each other, they built a global clock to keep time perfectly in sync, and only then did they start rolling out transactions. First for smaller setups, and then later for huge, globally distributed systems. Every single one of these steps was absolutely essential.
All right, so now developers have this incredibly powerful tool in their toolbox. But you know what they say, with great power comes great responsibility. You've got to use it wisely to make sure everything stays fast and efficient.
And MongoDB lays out some pretty clear best practices. Rule 1, keep your transactions short and sweet. Long-running ones can cause issues. Rule 2, keep them small. As a rule of thumb, don't try to modify more than 1,000 documents at once. 3, make sure your settings are configured for maximum data safety. And finally, and this one's super important, plan for things to go wrong sometimes. Build logic into your app to automatically retry a transaction if it fails because of something temporary, like a little network blip.
And here's the really good news, especially for developers. The code you have to write, it's going to look incredibly familiar. If you've ever worked with a SQL database like MySQL, what you see on the left looks almost exactly like the MongoDB code on the right. It makes jumping in and using this feature just super, super easy.
I love this quote from Stephen O'Grady, because it sums the whole story up perfectly. For so long, it was a forced choice, a trade-off. But now, well, developers can finally have their cake and eat it too. You get all the amazing flexibility of the document model, plus the ironclad guarantees of transactions that you just can't live without for some applications.
But let's end on the most important takeaway here. The document model is still the best practice. It's still the most powerful and efficient way to handle your data for that huge 80 to 90% majority of use cases. These new multi-document transactions are an absolutely critical tool for that last little bit. But they are a tool to be used alongside good data modeling, not as a replacement for it.
So where does this leave us? We're seeing these two old-school database worlds start to blur, borrowing the best ideas from each other. The old rigid lines in the sand are disappearing, which leaves us with a pretty cool question to think about for the future. When you're building your next big thing, the choice isn't really about this model or that model anymore. It's about figuring out how to use the best of both worlds.